Saxon Algebra 1/2, lesson 115. Caleb, I don't really like this lesson, and I'll tell you why. About half of it, you probably already know, and the other half of it, you'll probably never really need. So that depresses me and sucks a little bit of life out of me. But you know what? We're just going to forge ahead. Polygons. There's a lot of information in your book, so I'm going to slide that into the frame so that we can talk about it. A polygon is a geometric figure that has straight sides, right? As opposed to curved sides, which have another set of names. The most obvious one is a circle, right? But if it's got perfectly straight sides, it's a polygon. Its sides are line segments. Okay, it can have a cave. It has to be closed. Okay, no open gaps. I'm going to show you pictures of this in a second. It's okay to have a cave. Okay. This creates a shadow, I know, but this is not a polygon because it has a rounded side. This is not a polygon because it's not closed. This is a polygon because it's got a cave in it, but it meets all the other requirements. And this test always annoys me because John tries to talk about how there's this test where any 2 points within the polygon can be connected by a line segment that doesn't go outside the boundary of the polygon, right? But that's not true if you've got a cave, because I could put a point above and a point below and draw a line, and the line would go out. So I don't like that test, but that's the idea, is that any 2 points within the polygon can be connected by a line that stays within the shape. Okay, so for whatever that's worth, right? Different polygons can have different numbers of sides, and that changes the name. And so here we have them: triangle, quadrilateral, pentagon, hexagon, and it goes up from there all the way to 12. Okay, you probably already know triangle, quadrilateral, pentagon, maybe you know hexagon too. That's really about as much as we need to know, is up through 6. A polygon with more than 12 sides may be referred to as an n-agon. N-gon. So if it's got 15 sides, it's a 15-gon. Good to know. Maybe on Jeopardy someday you'll get that answer right. The place where 2 sides of a polygon meet is called a vertex. And the plural of that is vertices, which is always weird. When we put letters on polygons, the letter refers to the point. And so you can describe the shape by naming those points. And here John goes to a huge amount of trouble to show us all the different ways you could name that previous polygon by listing the letters. Honestly, in all of high school geometry and algebra, I've never seen this notation used, so that's cool. But, you know, good to know. Okay, this is fairly important. If all the angles of a polygon have equal measures and all the sides have equal length, it's called a regular polygon, okay? So regular means it's super uniform. So here are some examples of regular and irregular, only it's the other way around. The regular ones come second in the box. See, the first ones are a little wonky, but the second ones are perfect. Not every shape can be regular. For example, a rectangle is never going to be quote unquote regular because the sides have to have equal lengths, and by definition a rectangle has 2 different length sides. So these are the shapes we're going to spend more time looking at, these regular shapes, because we can do more interesting work with them. Diagonal of a polygon is just going kitty corner across a four-sided one. And then within just the quadrilaterals, within just the four-sided shapes, we have a lot of variation. This is the most perfect, this is the least perfect. A square has all the same, right? Same angles, same sides. A rhombus is if you take a square and squish it a little bit. You've ruined the angles, but you've kept the lengths of the sides. Now we start over again with a rectangle, perfect, and a parallelogram is kind of a squished rectangle, right? Again, we've got matching pairs of sides, but not all four match, like these guys, just 2 and 2, but here we squish the angles. And then a trapezoid is a freak child that has one pair of parallel sides, but the other ones aren't. Okay, so these words, if they're not already in your vocabulary, add them. And it's okay to look back at this, page 359. Remember that these two go together, these two go together, and then this is the roughest one. All right, these we'll talk about a little bit more in the next lesson. Okay, 2 other ideas. I hope you can see that. I know I'm casting a shadow now. We can rotate and change around the way we look at a shape. It's called spatial orientation. I bet you're good at it. We can move our shapes in different ways to compare them or analyze them however we want. The first one is called translation. Translation simply means we're sliding the piece around, right? We're not spinning it or flipping it at all. We're just moving it around. It's so subtle that that's even doing something that it's easy to miss that. All we're doing is literally sliding it into a different position. Rotation comes, imagine putting your finger at the point of this and then spinning it. That's what rotation is. We're literally rotating it like a pinwheel kind of, where the center stays fixed, but the bottom part spins around. And you can do that to any point. We could rotate it from that angle, or we could rotate it from that angle. And then reflection is the third type of change we can make, which is mirror image, right? We're flipping it. And we can flip it side to side, and later we'll talk about flipping it top to bottom as well. These are all called transformations. Here it is, translation, rotations, and reflections are called transformations, all right? And sometimes when we're reorienting a shape spatially, we use a combination of those. Okay, here's the practice. It somewhat annoys me. In this part, what we're doing is we're trying to come up with all the names of the shape as we possibly can. Okay, so this one could be considered, we right away see that it's a square. It could also be a rhombus that just hasn't been squished. It could be a rectangle. It could be a parallelogram, and it could also be a quadrilateral. John lists them from most general to more specific. I usually see that in my mind's eye. I see the most specific first, so I usually work in the other direction. So what he wants you to do is go through for each of these shapes and come up with as many names as you can. I'm not super impressed with that homework, but just do it. You can use the book. You can use the pictures in the book. And if you look at the answer and you've come up with 3 names and John's come up with 7, just look at the ones he got and make sure you understand why those names would be included too. Do not beat yourself up for 1 second if you don't get all the names on the first go. It's kind of silly. Did I say that out loud? Yeah, I did. Okay, so here you're coming up with names. And in this one, what John is telling us is that these 2 figures are alike, and he wants you to tell whether it's translation, rotation, or reflection that you would have to do to make the shapes line up. So for example, this one, here, I have to turn it so you can see it. This one I can see, oh, they're oriented perfectly. All I would have to do is slide A over and it would fit right on top of B. And sliding is considered translation, right? Yes. This one, we would have to rotate. We would have to flip it. So I put my finger on that corner and I push down on A. Oh, and then I have to flip it too, right? Because if I just twist it, if I just, let me use the right word. If I just rotate it, then the thick one is on this side and the skinny one would be on that side. We see how these two prongs are different shapes. So then they would be mirror image and I would have to reflect it over onto itself. So that's what you're doing, is you're imagining, how do I have to change the one on the left to make it look like the one on the right? And the three tools are reflection, rotation, and translation that are on the other page. So again, you can look at the book. These problems I think are a little bit more fun, but again, don't beat yourself up. Okay, that's the end of 115. Thank you, bye.